All right, so we're all in, huh? Okay, they're coming in. Yeah. Hello. Hi, everybody.
Hi.
Hi, this is Andres Martinez. Remember me? Welcome. Hey, welcome to Destination Space 2021. And in May, we have an incredible NASA scientist with us. He gave us a presentation last week. We toured the moon with the application that his group developed. And today we're going to talk about the lunar eclipse. The lunar eclipse is going to be taking place tomorrow morning, very early in the morning. Remember, Mr. Brian Day, he's the Deputy Staff Scientist at the NASA Solar System Exploration Research Virtual Institute. We know it as SURVEY. And he is also from NASA Ames Research Center. Remember, NASA's here in your backyard. We're only like 10 minutes away from your schools. We're basically in the same neighborhood. All right. And Mr. Day is going to talk to you about that total lunar eclipse that's going to happen tomorrow morning. So everyone, please welcome Mr. Day. Remember, we only have only one rule. And all of us have to mute our mics, including myself, all of us. The only microphone that will be open will be Mr. Day so that he can tell us all about the lunar eclipse that's going to take place tomorrow morning. Okay? All right. So everyone, please welcome Mr. Day and mute your microphones. All right? Okay, Mr. Day, please take it away.
Thank you very much. I appreciate it. And I appreciate all of you letting me join you once again. We have, as Andres explained, a very exciting event coming up. And so I'm going to talk to you about tomorrow morning's eclipse and eclipses in general. So ever since people have been looking up at the sky, they have noticed some really interesting things. So occasionally, the big full moon would disappear, either part of it or all of it. And sometimes, instead of just completely disappearing, it would turn a deep blood red. Well, that got everybody's attention. And sometimes the same thing would happen to the sun. Up in the sky, something would start covering the sun. The sun would start to disappear. And again, this would be of great concern to people. They didn't really understand what was going on. Every culture had its own idea. For instance, in ancient Chinese society, they imagined an invisible dragon living in the sky that would get hungry and occasionally take big bites out of the sun or the moon. Back in many centuries ago, there was a war going on in present-day Turkey between the Lydians and the Medes. And this war had been going on for 6 years. And it had reached a climactic battle. And the two armies met on the battlefield. And they were really about to have it out when all of a sudden the sun disappeared in the sky. They took that as a sign to mean the gods were unhappy with them. So both armies packed up, went home, and an eclipse ended a war. Well, we now have a better idea of what's going on with eclipses. We know that the moon orbits around the Earth, circles around the Earth once about every month, 28 days. And the Earth and moon together go around the sun once every year. And what this means is sometimes the Earth is lined up between the sun and the moon. And when that happens, the Earth's shadow can get cast on the moon, causing a lunar eclipse. And also sometimes the moon can come between the Earth and the sun. And in that case, the moon's shadow gets cast upon the Earth. And then we have what we call a solar eclipse. So let's take a look at the players involved in these eclipses. We have the Earth and the moon. This picture is to scale in terms of size. So the Earth is about 4 moons across. But this is not to scale in terms of distance. This is not how far the Earth and moon are from each other. Actually, they're much further apart. The moon is actually 30 Earth diameters away from the Earth. That's a long way, 240,000 miles. The other character in our play here is the sun. The sun is much bigger. The sun is huge. The sun is 110 Earths across. If the sun were hollow, you could fit 1,300,000 Earths inside of it. But the big point here is that even though the sun is 400 moons across in size, it is 400 times further away from us than the moon. That means that the sun and the moon appear the same size in the sky to us. And that turns out to be very, very fortunate for us. So again, when we take a look at a lunar eclipse, that is when the moon has gone around behind the Earth there, and so the Earth's shadow covers the moon. This is very different than the phases of the moon that you see during the course of the month. When you look up and at different times of month, you see part of the daylight side of the moon and part of the nighttime side of the moon. This is very different. Instead, what we have is the moon, normally in its full moon position, getting covered by the Earth's shadow. Now, remember I mentioned that the eclipsed moon can turn deep red. And that wouldn't happen if the Earth didn't have an atmosphere. But the Earth does have an atmosphere. And that atmosphere scatters red light more strongly than light of other colors. And you've experienced that yourself. You've seen sometimes after the sun sets in the evening, and you see how you can get those beautiful red sunsets in the sky. And so that last remaining sunlight gets scattered by the Earth's atmosphere. It's that red color that gets scattered the most. Now imagine if you're sitting on the moon and watching the sun go behind the Earth. That whole rim of the Earth's atmosphere would light up red with the sun having set essentially behind the Earth. And that glowing band of red around the Earth is what illuminates the moon and causes that deep red color. Now, if the moon goes around the Earth once every 28 days, a good question is, why don't we see an eclipse every month? Every time the moon would be full, you might think, well, we should have an eclipse. But it turns out that the moon's orbit around the Earth is tilted compared to the Earth's orbit around the sun. What that means is most of the time, the moon will pass either above the Earth's shadow or below the Earth's shadow, and we won't have an eclipse. But occasionally, when things line up just right, the moon will pass through the Earth's shadow. It might pass through so that only part of the moon goes through the shadow, in which case we have a partial eclipse, or the moon might pass completely through the Earth's shadow, in which case we have a total lunar eclipse. So here's a picture of a partial lunar eclipse. You can see that part of the moon is covered there by the Earth's shadow. Here's a picture I took of a total lunar eclipse. And this happened in 2011. let's see here. Here's a wider view of that. And you can see how the moon is red. This is looking out over the lights of San Jose. Now, here's another eclipse that I took. And you notice it looks a little bit different. That's neat because no two total eclipses of the moon are the same. That's because in each eclipse, the moon might pass into a deeper or less deep part of the Earth's shadow, but it's also because the Earth's atmosphere is different. I've seen the moon completely disappear after a big volcanic eruption put a lot of dust in the Earth's atmosphere. And that made the atmosphere especially thick and dark. And so the moon did not get illuminated by that red light. Here you can see another eclipse. And if you look down and to the left, there's what looks to be a little star. And that is, in fact, the planet Uranus that was in the background. So it kind of decorated this eclipse for us. In 2015, I got this picture of an eclipse. You can see here, this part of the moon, the lower left is deeper in the shadow. In the upper right, it's just barely inside the shadow. And so you see differences in shading across the moon. That's something to look for in the morning. And here's one of my favorite pictures I took of a lunar eclipse. This is centered on the Earth's shadow in space. And I took 3 different exposures while pointing the telescope this way. And you can see on the right, the moon entering the Earth's shadow. In the middle, the moon in the central part of the eclipse. And then on the left, the moon leaving the Earth's shadow. What you see here is the moon, the Earth's shadow is much bigger than the moon in the sky. And you can also see here that in this eclipse, the moon did not pass through the center of the Earth's shadow, but kind of toward the side. And so one part of the moon is much darker than the other. So we have an eclipse coming up tomorrow morning. And this is going to be really, really exciting. The eclipse will, the first bite out of the moon will seem to happen at about 2:45 in the morning. Ooh. Totality, that means the moon will be completely swallowed in the Earth's shadow, will be at 4:11. And that'll continue until 4:25. So what we'll do is let's preview what the eclipse is going to look like. So I've generated a preview using my computer. So here we go at 2:45 in the morning, just before 2:45, you'll look up and you'll see the full moon. 10 minutes later, if you look, you'll see this bite taken out of one side of the moon. And 10 minutes later, the bite grows bigger and bigger as the moon is moving into the Earth's shadow. We keep watching the moon going in deeper and deeper. And then finally, at 4:11, the moon is completely inside Earth's shadow. It will probably be very dark red in color. And then at about 4:26, the moon will start to come out of the Earth's shadow. We'll see more and more of the moon reappear. And the moon will be getting lower and lower in the west toward the horizon. And as the eclipse starts to come to an end, the sky will brighten with dawn arriving, and the moon will be out of the eclipse just before it sets at sunrise. So that's what to expect tomorrow. Let's hope the weather cooperates. Now we're actually going to be really, really lucky here. We've got a series of lunar eclipses coming up. So we have this one tomorrow. We've got another one coming up this November. It's not going to be quite total, though. This will be 97%. A little bit of the moon is going to be sticking out just outside of the Earth's shadow, but it still should be really neat to watch. And next May, a year from now, May 16th, we will have another total lunar eclipse. And this one will be a little easier for us because this one will happen in the early evening. Just as the sun sets, the moon will rise above the eastern horizon. And as the moon rises, you will see that the eclipse will have already started. Part of that full moon will be missing. And as the moon rises higher and higher, it'll get more and more covered by the Earth's shadow. And so this will be an evening eclipse that we can watch instead of having to get up in the middle of the night or really ridiculously early in the morning. So we're really lucky here. We've got a number of really cool lunar eclipses coming up. But what about this other type of eclipse I mentioned? We talked about a solar eclipse. And again, this is when the moon comes between the sun and the earth. Now remember, the moon is a lot smaller than the earth. And so its shadow is a lot smaller than the earth's shadow. And so the shadow of the moon does not cover the entire earth. Instead, the shadow of the moon will trace a narrow path across the earth, and places within that path of that shadow will get to experience a solar eclipse. Here's a view of the earth taken from space during an eclipse, and you can see this dark area where the moon's shadow is. Here's another picture of a solar eclipse happening, viewed from space, and you can see the moon's shadow shining on the cloud tops here on Earth. So when we talk about a solar eclipse, we should try and get a little bit better understanding of the sun, because the sun is really putting on the show for us. The sun has different layers. Now, the layer that we're all used to, the bright, blinding layer of the sun that you can see if you go out during the daytime, you don't want to look at it, it's so bright. This is called the photosphere. This is a picture I took of the solar photosphere through one of my telescopes using a very special filter. And we can see here sunspots, giant magnetic storms on the surface of the sun. These smaller sunspots are about the size of the Earth. Pretty impressive. But again, this is the solar photosphere. Now, just outside the photosphere is this beautiful red layer called the chromosphere. Now, the chromosphere is not blindingly bright like the photosphere is. It's actually much dimmer. It's something that you would normally be able to see just looking at it with your eyes, except for the fact that the photosphere is so bright that it glares out this layer. But using a special telescope or during special times like a total solar eclipse, we can get glimpses of this inner atmosphere, the inner atmosphere of the sun, called the chromosphere. Again, it's this beautiful red color, and we see these beautiful eruptions called prominences coming off the edge. Some of these eruptions are about 10 Earths tall. This is really spectacular to watch. And then outside of that, we have the sun's outer atmosphere, or the corona. Very beautiful, very wonderful to see. And again, it's safe to look at if you don't have the blinding bright light of the solar photosphere in the way. So sometimes the moon just covers part of the sun, in which case we have a partial solar eclipse. And here you can see a picture I took of a partial solar eclipse. Here's the moon passing in front of part of the sun, Here you can see the solar photosphere, and here you can see a big, giant sunspot group. Really, really impressive. This is a wider view of that same eclipse. I took this in La Paz, Mexico, and it was late in the day. You can watch as the sun set. We had our first little bite up here, then a bigger bite, and then it started disappearing just before the sunset. This was a lot of fun to watch. Another type of solar eclipse is what we call an annular solar eclipse. And in this case, the moon comes directly between the Earth and the sun, but the moon is further away from us than usual. And because it's further away from us, it appears smaller in size. It is so small here that it doesn't completely cover the sun. So as a result, the sun turns into this bright ring in the sky. Very, very special. Here's a picture I took of an annular eclipse over the Grand Canyon. And you can see we start out with a little bite here, a bigger bite, and then the moon completely inside the ring of the sun, and then the moon starting to move out just before the sunset in the Grand Canyon. Now I want to explain to you about the best of the solar eclipses, a total solar eclipse. So the eclipse begins with something like this, the moon covering part of the sun. Looks like a partial solar eclipse. Now again, to look at the moon or to look at an eclipse like this, you need to be very careful. You need to have special filters, special glasses. You don't want to look at the sun with your eyes. Looking at this photosphere can damage your vision. You never want to stare at the sun. But with special filters, we can get pictures like this and you can safely view the sun. So the eclipse starts out like this, and over the course of the next hour, you have more and more of the sun getting covered by the moon. Now, by this point, the sky is starting to get a little bit darker, even though the sun is high overhead. It's starting to look like, late dusk. And as the last remaining bit of the sun turns into a thin sliver in the sky, the brighter planets start popping out. And as that last sliver gets ready to disappear, across the ground, you have these zebra-striped shadows racing across the ground at very high speed. We call them shadow bands. And if you look at them, you can get dizzy because all of a sudden the ground looks like it's moving. And as you look up from the shadow bands, you look to the west, and all of a sudden you see this great big black wall rise up out of the horizon like some huge dark tidal wave. It rushes over you at over 1,000 miles an hour. It is the moon's shadow coming down through our atmosphere. The shadow washes over you. And the last bit of the solar photosphere shines through the rough edges of the moon between mountain peaks, where low valleys allow just that last little bit of the solar photosphere to show up. We call these Bailey's beads. And then they disappear and we get a glimpse safely. Now you can take off your glasses. Now you can safely look at the sun and you see this beautiful red band of the solar chromosphere. You look out around and the sky above is dark. The brighter stars and the planets are shining, but all the way around the horizon, you have a 360-degree sunset. It's really very amazing. The temperature drops, birds go to roost, animals start going back to their barns, and you look up at the sun, and the sun is got these beautiful eruptions of prominences standing out, and this beautiful shining solar corona, its outer atmosphere, stretches out in these beautiful jets and streamers. It is a wonderful thing to see. People are yelling, screaming, crying, jumping up and down, laughing, passing out even. It's a very emotional experience. And then after a few seconds to a few minutes, the Bailey's beads appear as the moon starts to move out from in front of the sun, and the totality comes to an end. So we have a couple of solar eclipses to look forward to. The next big one that's going to be visible from here will be in 2023, and that'll be one of those annular solar eclipses, one of those rings. And the path will go from the Pacific Northwest through like New Mexico and Texas. We will see it here in California as a deep partial eclipse. But if you travel to like Albuquerque, New Mexico, then you'd be able to see the sun as a ring. And then the next total solar eclipse that will be visible from here in the United States will be in 2024. And there it'll take a path going through Mexico. It'll go right across Mazatlan on the Pacific coast. And they'll come up through Texas and cross through the middle of the United States and go out through the Northeast. Again, here in California, we'll see it as a partial eclipse. So those are some fun things to look forward to. But for now, I want to remind you that we have a wonderful total solar eclipse scheduled for this coming morning, tomorrow morning. Again, the partial phase will begin just before 2:45 in the morning, and the moon will get completely swallowed by the Earth's shadow at 4:11, and it'll start to come out again just before 4:26. So I hope you all have clear skies and a good view of this exciting lunar eclipse. Okay.
Brian, once again, your presentation was amazing. And I have to say that I started getting chills again because I was one of the lucky, not lucky few, but I traveled up to Madras for the last eclipse. And it was, one of those things that I understand why folks spend, their time and money
Yep.
hopping across the globe. It was one of those hopefully not once in a lifetime opportunities. But
Yeah,
what we'll do,
it is.
go ahead.
I should warn people. This is habit forming, and I now have chased eclipses all around the world. And one of the great things is you meet wonderful people. You go to places you wouldn't otherwise go to. You try amazing food. It's a great, great thing to do. So if we have any questions, I'll be happy to try and answer them.
Okay, so it looks like Kiana Mendoza has been waiting so patiently. So if you want to go ahead and unmute yourself.
My question is, how often do solar eclipses happen?
How often do solar eclipses happen? They happen somewhere on the Earth, typically about every year. But the thing is you have to be in the right place. Remember, the moon's shadow going across the Earth is a very small thing. So if you just sit in one place, you could wait for centuries before you see an eclipse. But if you're willing to travel and you go to where that shadow is going to be, then you can see them much more often, every few years. Now, lunar eclipses are a little easier to see because, again, the Earth's shadow is so big, it covers the entire moon, And so the only constraint for a lunar eclipse is you have to be on the side of the Earth that is facing the moon at that time. So in this case, a little over half the Earth will get to see the eclipse tomorrow. But those poor people that are on the side of the Earth that's experiencing daytime, they're going to miss the eclipse. So, a little over half the Earth will see tomorrow's eclipse, weather permitting. Okay.
Let's see. What about Jeremiah? You want to unmute yourself?
Um,
Okay, there we go.
when are solar eclipse normally, like what time are they normally?
So solar eclipses can happen. I've seen them early in the morning and I've seen them late in the day. One of my favorite solar eclipses, a couple of times I've watched solar eclipses happening as the sun set. Put myself on a nice beach and watched an eclipsed sun set into the ocean. That was a really special view. But they can, depending on where you go, where you meet that shadow of the moon as it goes across the earth, you can see an eclipse at pretty much all different times of the daytime. Of course, you will never see a total solar eclipse at night because the sun has to be in the sky to see a solar eclipse, right? Okay.
Okay, what about Matthew 10? You want to go ahead and unmute yourself?
Does the eclipse happen on the day or in the night?
Well, you will see lunar eclipses at night and you will see solar eclipses during the day. Now, I just want to remind everybody, big difference between lunar and solar eclipses. Solar eclipses, you need to protect your eyes. You need those special glasses. Lunar eclipses are totally safe to look at. You don't need glasses. You don't need a telescope. You don't need anything. Just go out with your eyes and enjoy the wonder of a lunar eclipse. So this lunar eclipse tomorrow morning, perfectly safe to look at, perfectly enjoyable. Go out and do it. But again, lunar eclipses happen during the night. Solar eclipses happen during the day.
Okay, what about Quen Ho from Mr. Trans class?
So, how many times did you see the lunar eclipse?
Oh, how many times have I seen a lunar eclipse? Oh, I know I've seen probably about at least 30 of them. And I've seen, probably about 15 or so solar eclipses. They're lots of fun. Like I say, they can be habit forming.
All right, we're going to do one last question.
Let's see. Antonio, go ahead. Thank you for being patient. You wanted to ask a question a long time ago.
But what happens if something wrong happens when the lunar eclipse or the solar eclipse? What happens if something very wrong happens?
Well, there's not much that can go wrong during an eclipse other than, now this is the thing that has really bugged me. I have had an occasion where, for instance, I went all the way to Costa Rica for a solar eclipse. It was beautiful. We were set up on a beautiful beach, and we had our telescopes, and we had all our special filters, and we were going to see this beautiful, wonderful eclipse. And we're set up on the beach, and as we're looking out over the blue ocean and the beautiful blue sky, there was one little puffy white cloud. And the white puffy cloud is moving along, and it's getting closer and closer to the sun. And this eclipse is getting closer and closer. We go, oh, this might be bad. And guess what? That little puffy cloud parked itself right in front of the sun, right when the eclipse happened. We got all that way to look at a puffy cloud.
Oh no. Oh no.
Oh. So that's about as bad as it gets.
Yeah, that was a bad timing. Hey, so I just realized that I think Mateo has a really good question. So let's do Mateo. Mateo, you want to open up your mic? You have a really good question? Yes? You thinking about it? It says Angelica and Mateo. Yeah? Open up your mic, Mateo. What's your question?
Okay.
Doesn't open up? There you go.
What happens if you see a solar eclipse with your eyes?
Well, if you look at it directly without any protection, you can hurt your eyes and you can damage your vision. But there are ways, and what we'll do is we'll do something in the coming, maybe the coming school year, where I can talk to you about how to view the sun safely. And that'll include how to look at a solar eclipse. But you never, solar eclipses aren't any more dangerous than looking at the sun in general. But you never want to look at the sun. The sun is really bright. Now, normally you don't have a reason to look at the sun, but when a solar eclipse is going on, people get tempted to look up at it.
Mm-hmm.
What we can do is we can teach you the safe ways to observe the sun. And I can even bring a special telescope to your school.
Yes.
You can look at the sun safely. But you always, always, always need to use special protection when you look at the sun, because the sun is just too bright to look at without that special protection.
Okay. Okie doke. Well, can everyone help me give Mr. Day a big round of applause? Wasn't this amazing? Did everybody learn a lot about exploring the moon? And today we learned a lot about lunar eclipses. All right, so this is the point in time where we take a nice photo with Mr. Day. All of you, I invite you to open up your video cameras and to give me a big smile. If you're gonna make a goofy face, if you wanna be funny, make sure it's a face that's gonna make you look good, okay? It's okay if it's funny. Okay, ready? Okay, it says Queen Ho. Are you gonna be in the photo? There you go. All right, thank you. Yeah, that's a nice one. 1, 2. Okay, let's see how the camera did. Oh, I love it. All right.
And
okay,
if I could make one special announcement real quick.
Yeah.
We talked about, last week we talked about Moon Trek.
Mm-hmm.
And everybody Moon Trek. and how that was just one of our solar system trek portals where you can explore many different worlds like the moon. I want to make the first public announcement of something, your group here. We have just released a new trek portal that allows you to explore Jupiter's moon, Europa.
Oh
That
my,
is a brand
wow.
new announcement. You are the first people that I'm announcing this to. And so if you go to Trek, that's trek.nasa.gov, you can explore the moon, you can explore Mars, you can explore Mercury, you can explore all kinds of other worlds, you can explore asteroids, and you can now explore Europa. So I want to thank
Amazing.
you all.
Hey, congratulations, Mr. Day.
Thank you.
Good work. Okay, so this is Mr. Brian Day, one of our awesome scientists that we have at NASA Ames. And remember, NASA Ames is just, it's in your neighborhood, just about 10 minutes away from your schools, all right? This is why you are very special to us, because we're in the same neighborhood with you guys. This is why you guys, okay, I forgot to ask, did everybody do their homework today and their classwork? I don't see any hands being raised. Okay, I see one. Okay, let's see. All right. Don't forget, it's very important to do your homework, your classwork, your chores at home. You gotta help your parents, right? You have to clean up. You have to be an all-around incredible person, okay? In your community, in school, everywhere you go, people need to notice you as being an incredible person, because guess what? When you grow up and you go to college, we're gonna notice how incredible you are, and you're gonna be walking through our doors. You're gonna be helping us. You're gonna be doing presentations for Destination Space 2035. Okay, you're gonna come back and do presentations just like we did, because you're gonna be engineers and scientists or other type of professionals at NASA. You're very special to us. So this is where we've been. We started in February, and we told you all about Mars. The engineers and scientists that are actually working or worked on Perseverance and Ingenuity came and told you about everything they did. Remember, we were even together when Perseverance landed on Mars. And then in March, we told you all about Artemis, the people that are working on Artemis and going back to the moon, our most powerful rocket, our new spaceship, the astronaut suits. They came and they told you, right? When all of this is going to be available. And then last month in April, we invited a bunch of scientists, marine biologists, to come and talk to you about planet Earth, because we celebrated planet Earth, our beautiful home. And then in the month of May, we have one special guest. We just had our second presentation by Mr. Brian Day. So we're done. We're done for the year. This is Destination Space 2021. Incredible talks just for you, our very special future generation of future professionals, engineers, scientists, teachers, doctors, psychologists. You guys are gonna do so amazingly well, but remember, you have to do your homework. That's the key. Without that, it's gonna be really hard, okay? You gotta do your homework. You have to develop these good work habits, okay? And then when you do that, everything is gonna be a piece of cake upside down. Believe me, I remember that, okay? All right, everyone, thanks for joining us. We will see you, hopefully next time we see you, it's gonna be in person at one of your schools where Mr. Brian Day and a bunch of all these people that I presented to you are gonna come, and you're gonna get to meet us in person, okay? All right, we'll see you, take care, be safe. I know your school year is almost over. Make sure you do really well all the way through, okay? All right, everyone, take care, stay safe. Bye-bye.
Thank you so
Bye.
much. Bye. 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 One day.